Alright, welcome back. So we are continuing from part one. So the next type of equation that we're going to look at, or the next type of chemical reaction, is decomposition. And in this one, we're going to have one compound, right? And we're going to apply heat. You have different forms in which a compound can be broken down, right? So for these two, it's called thermal decomposition because we're using heat, right? So a single reactant is broken down into two or more products. So there are rules. If you want to remember what to do, just know that the carbonate, right, when you have a metal carbonate, like calcium carbonate, you are going to get two things. You are going to get the metal oxide. If you are going to get the metal oxide plus oxygen, right? Oxygen gas. So calcium carbonate, that's the metal carbonate, is supposed to get the metal oxide, right? Now I'm just going to write the formula. I'm not going to work it out. If you need to practice, you can practice on your own. Watch the video that I did on formulas. But at this stage, you must know how to write chemical formulas, right? So calcium carbonate, if you heat it, it will be broken down into the metal oxide. So you will get calcium oxide, right? And oxygen, right? That's it. So you just need to know that once it's the metal carbonate, you will get the metal oxide plus oxygen gas. So for magnesium carbonate, you can pause it and try it. If magnesium carbonate decomposes, what will be produced? Right? So again, you should get the metal oxide, which is magnesium oxide and oxygen gas. Alright? So that's the first one, metal carbonates. We're going to look at the metal nitrates next. Alright, so for this one now, we are looking at the decomposition of metal nitrates. So with the carbonates, you get the metal oxide and oxygen gas. However, with the nitrate, you are getting three things: metal oxide, nitrogen dioxide, and oxygen. So once it's nitrate, you are supposed to get nitrogen dioxide and oxygen gas. Alright, so if you have lead nitrate and you heat it, it will decompose into the metal oxide, which is lead oxide. So that's PbO, because we know that the charge on lead is 2 plus, the oxide is 2 minus. You're supposed to get nitrogen dioxide, so that's NO2, and it is a gas. And we are going to get oxygen gas as well. So it's not difficult. Once you have metal nitrate, you know the products you are supposed to get, and that's it. Metal oxide, nitrogen dioxide, and oxygen gas. So if it's calcium nitrate, you should be able to do these. So you can pause the video and try them. Alright? So let's continue. Calcium nitrate, the metal oxide. Let me not use let me use other than calcium. Let me use aluminum. So I will get, so aluminum oxide to be Al2O3, right, plus NO2 plus O2. Right? Now for the group 1 metals, right? For group 1, there is a little adjustment. So lithium it will react just like the other metal nitrates, in that you will get the metal oxide, so lithium oxide plus NO2 plus O2, right? But the other metals in group 1 will not do that, alright? You will not get the NO2, so it would be potassium oxide and oxygen, yes. Alright, so when you react metal nitrates with, when you heat the metal nitrate, you are going to get the metal oxide, nitrogen dioxide, and oxygen, as you can see here. But the exception now is with group 1. Alright, so the group 1, once it's above lithium, so sodium, potassium, right, you will get the oxide and oxygen gas. But for lithium, you will still get NO2 and oxygen. So it's just the group 1 metal is the exception, alright? In the other scenarios, you will get the nitrogen dioxide, alright? So that's the composition of the nitrate. We are going to do some more decomposition again. Alright, there's an error. It's not potassium oxide, it will be the nitrate. So if it's potassium, so if it's sodium or potassium, it will be potassium nitrite or sodium nitrite. So these are the exceptions. But the lithium, it will be lithium oxide, NO2 and oxygen. Alright? So the exception, sodium nitrate, potassium nitrate, they will give you potassium nitrite and sodium nitrite plus oxygen. So these are the exception. Alright? So now we're going to do the thermal decomposition of hydrogen carbonate. Alright, so in this one, so it's just a rule again. If you have the metal hydrogen carbonate, example, sodium hydrogen carbonate, you get the metal carbonate. Metal carbonate. So any metal hydrogen carbonate, so if it was potassium, magnesium, you're going to get the metal carbonate, CO2 and water. Alright, and that's basically it. Alright, so we're going to look at a different type of chemical equation now. Alright, it's called single displacement. So we're going to do that one now. Alright, so the next reaction now is single displacement reaction. So it means that if you notice, we have an element reacting with a compound, right? So single displacement means that the isolated element is going to displace an element from the compound. Now, if the isolated element is a metal such as zinc, magnesium, right? So if the isolated element is a metal in the compound, or if it's a positive, if it will form a positive ion, it will displace the next one. So zinc reacts with copper sulfate. We know that the sulfate is a negative ion, SO42 minus. The copper is the metal, or it is the positive ion, copper 2 plus. So in this displacement reaction, the metal will displace the positive ion. So if you notice, zinc plus copper sulfate gives you zinc sulfate plus copper. Alright? So zinc displaces the copper. So copper is now on its own, so it goes back to being the atom. So that is why you have copper atom. It's a solid because we know that metals are what? Solid atoms, right? So the zinc solid, if you notice it says aqueous, that means we have a solution of copper sulfate. So if you put zinc metal in a solution of copper sulfate, then the zinc displaces the copper, right? And joins up with the sulfate. So you get zinc sulfate. And now copper is on its own. If you look on the reactant side, zinc was on its own, but on the right side, copper is now on its own because zinc replaced copper. So you have zinc sulfate, right? Here we have magnesium reacting with HCl. So as you can see, what happened? The magnesium displaced the hydrogen. So the chloride ion is the negative ion, hydrogen is the positive ion. So the metal displaced the positive ion. So you get magnesium chloride. Now hydrogen does not exist as an atom. So you don't have a hydrogen atom, right? That's not how hydrogen exists. It is a diatomic molecule. Therefore, when the metal displaces hydrogen, you are not getting an atom of hydrogen, you are getting a molecule. That is why you have H2 here. Copper is a metal, it exists as an atom, right? Metal atoms. That is why you have Cu. But hydrogen, it exists as a gas. That means if you place magnesium in HCl, hydrochloric acid, you will get hydrogen gas being produced. Alright? Now, these two now, if you notice here, the isolated compound or the isolated molecule here is a non-metal. Alright? So remember, when the isolated atom was a metal, it would displace the positive ions. Now the isolated atom here is a non-metal, so it is going to displace here negative ion, the bromide ion and the iodide ion. So if you have potassium bromide with chlorine, the chlorine is going to displace the bromine, the bromide ion. And so you get potassium chloride and bromine. Now again, bromine exists as a diatomic molecule. So you will not get Br. You will not get Br. That's not how it exists. It exists as a molecule. So two atoms of it, right? So it's Br2. So these elements are in group 7. Bromine, chlorine, fluorine, iodine, they are diatomic. So when they exist on their own, it's always I2, Br2, Cl2, F2. Alright? So when you have a salt, so it's KBr, right? A compound here, and you are reacting it with an isolated non-metal, alright? It will displace the other one. Alright, so this one is specifically for group 7 elements. Alright, so chlorine displaces bromine, so you get KCl and Br2. Now if you have sodium iodide and you react it with bromine, bromine is going to displace the iodine, and so you get sodium bromide and iodine. And to test if you understand it, what if you have magnesium chloride, right? And you react it with fluorine gas, what would you get? You can pause the video and try. So you should know that the fluorine would displace the chlorine. So you would get magnesium fluoride, that's MgF2, and Cl2. Alright? So, single displacement reaction, what is occurring? An isolated atom is replacing an ion from a compound. Alright? So zinc replaces copper, magnesium replaces hydrogen. In this one now, you are comparing two negative ions. Alright? So the non-metal replaces the negative ion. Now, in different aspects of the chemistry, you will understand why chlorine displaces bromine, right? Why zinc displaces copper, right? So this will come on the topic oxidation and reduction. So when you're doing that topic, you will understand, alright? And I will tell you why at the end. Alright, so that's it for the single displacement reaction. Next, we are going to do the double displacement one. Alright, so the double displacement reaction is also called the Ionic Precipitation reaction. So in this one, right, you have two ionic compounds, right, but both of them have to be able to form a solution. That is why every state symbol you see, it is aqueous. Now, when you have a reaction like this, right, double displacement, the positive ion from one of the solutions, well, one of the ionic compounds will combine with the negative ion of the other one. So in this, the silver ion is the positive ion, because you know positive ion precedes the negative ion. So the silver ion will combine with the chloride ion. So positive ion of one of the ionic compounds combines with the negative ion of the next one. That means the potassium ion will combine with the nitrate ion. Right? So it's not like the case before where you have an isolated atom replacing an ion from a compound. We are doing two displacements. So silver combines with the chloride ion, and the potassium combines with the nitrate ion. So therefore the products would be silver chloride plus potassium nitrate. Right? Now it says ionic precipitation. That means you're going to get a precipitate, which is a solid. Silver chloride, it will be a solid. And at the end of the video, I will give you the reasons why these will form solid, but this will remain aqueous. Alright? So all of these equations have rules attached. So you will know that once the compound is a nitrate, it will be soluble, so it will be a solution. That is why it's aqueous. But silver chloride, it's not going to be a solution because it is insoluble, so it will form a precipitate, which means it is a solid. So at the end I will give you the rules. So you can try this one, pause the video if you need to, and try it. Alright? So the lead ion will combine with the negative ion, which is the iodide ion, and the potassium ion will combine with the negative ion, which is the nitrate ion. So you would get lead iodide, PbI2, and potassium nitrate. Alright? So those are the examples of double displacement reactions. You have solutions, right? Two ionic solutions, and the positive ion from each, basically, they switch places. So silver switch place with potassium. Therefore, you get silver chloride and potassium nitrate. But The reason why it's called ionic precipitation is because these are ionic compounds and one of them will form a precipitate. So both of them were solutions, but when this switching occurred, the new compound formed, the new ionic compound, one of them was insoluble. So it stayed as a solid, whereas the other one was soluble, so it stayed as a solution. So silver chloride is insoluble, that is why you get the precipitate, a solid. And the potassium nitrate is soluble, so it stayed as a solution. Lead iodide is insoluble, that is why you get it being a solid. Alright? Alright, so the next equation, or the next type of reaction, it's called neutralization. Alright, and this takes place with an acid. So when you do the topic acid, bases, and salts, we will look at that in details. So an acid, so basically to identify it, once you have an hydrogen atom, a hydrogen ion attached to the negative ion, that is basically how you would identify the acid. So HCl, that's an acid. H2SO4, that's a next acid, right? But we're just focusing on the equation and not acids per se, alright? So when you have the metal hydroxide and you react it with hydrochloric acid, what will happen? Your metal, so the positive ion of the hydroxide will combine with the negative ion of the acid. Alright? The positive ion of the hydroxide will combine with the negative ion of the acid. So the acid is always the hydrogen ion attached to a negative ion. So you just combine the sodium ion with the negative ion of the acid. So it is sodium chloride. And the hydrogen ion and the OH ion will come together and form water. So in neutralization reactions, you get a compound, an ionic compound, and water. Alright? We have specific names for these compounds, a general name, but again, that's for when we're doing acid, bases, and salts. So once you see the metal hydroxide with the acid, the positive ion of the hydroxide ion, it is going to combine with the negative ion of the acid. So sodium chloride, NaCl. Alright? For this one, when you have the metal oxide, right? So it was metal hydroxide. Now it's the metal oxide, and the next acid, the same thing will happen. The positive ion of the metal oxide combines with the negative ion of the acid. So the sodium ion combines with the sulfate ion, and so you will get sodium sulfate. Now, when it's the metal carbonate, you're not just going to get the ionic compound and water. You're going to get carbon dioxide as well. So once you see the metal carbonate with the acid, you are going to do the same thing. Positive ion of the carbonate with the negative ion of the acid. Alright? Now, the hydrogen of the acid and the carbonate ion of the base, those will go to form carbon dioxide and water. Alright? And the final one is the metal hydrogen carbonate. Again, positive ion with the negative ion. So sodium with chloride ion, I get sodium chloride. The carbonate ion and the hydrogen of the acid. So the hydrogen carbonate ion and hydrogen of the acid, those go to form carbon dioxide and water. So what should you remember from all of this? When you have metal carbonate or the hydrogen carbonate and you react it with an acid, you will get carbon dioxide and water as well as the ionic compound, which is formed from the positive ion of the carbonate and the negative ion of the base of the acid. Alright, so that's your acid. Alright, that's your acid. Good. If it's the hydroxide or the metal oxide, you don't get any CO2. You get the ionic compound and water. Alright. Now, these you can use them in the solid form or you can make a solution with them. Alright, so if you see aqueous, it means that we're using a solution. If you see solid, it means we're taking up some of the solid compound and adding it to the solution of the acid. Alright, so just ensure that you remember what to get when you react a particular compound. So when it's the metal hydroxide with the acid, you get the ionic compound, which is formed, right, and water. Once it's the carbonate or hydrogen carbonate with the acid, you get an additional compound, CO2. Alright, so that's it for neutralization. The final one will be combustion. Alright, so the final reaction we're going to look at is combustion. And we know combustion refers to burning a compound in air. When we say air, we are referring to oxygen. Right? So the first reaction we did with magnesium earlier and oxygen, this is actually combustion. Right? So I will actually do this reaction in our next video and let you see it. Right? So when you burn magnesium, so you light it, right? It reacts with the oxygen in the air. That's how we get magnesium oxide. So combustion, you are reacting a compound with oxygen. Now if the compound consists of carbon, hydrogen, and oxygen, you will get carbon dioxide and water, right? So if it consists of carbon and hydrogen only, you can get carbon dioxide and water, right? So glucose, this is a hydrocarbon. So hydrocarbons, alright? So like propane, methane, all of those hydrocarbons, when you burn them, you get carbon dioxide and water. Of course, it's a lot of heat, so the water is in the vapor state, not a liquid. So when your hydrocarbons react with oxygen, you get carbon dioxide and water. In cellular respiration, glucose reacts with oxygen, you get carbon dioxide and water. And when you react metals with the oxygen, when you burn them, you get the metal oxide. Alright, so combustion, if it's a hydrocarbon, you get carbon dioxide and water. But for like the metal with the oxygen, you get the metal oxide. Alright? So with combustion, you are reacting a substance with oxygen. So you are burning the substance in air. So combustion, basically burning, alright? So that's the final reaction. I'm going to do a next video to remember the double displacement equation and single one. There are certain rules as to why you get those. Alright? So I'm just going to close this one here and explain that in the next video so that you can know when it will form a precipitate or when it will stay as a solution. So for now, just go back over each equation, each type of reaction and know what will be the products based on the reactants. So if you see a compound with just carbon and hydrogen, so if you see C3H8 reacting with oxygen, you are supposed to know that it is a hydrocarbon. It just consists of carbon and hydrogen, and so you should get carbon dioxide and water. Alright? Again, if you saw aluminum and oxygen, you should know that you are supposed to get aluminum oxide, because metal and oxygen, metal oxide. Alright? So that's it for combustion. Again, if you have any questions, you can ask it in the comment section, or if you want to reach me, you can reach me on IG. Alright, so that's it. Remember to like, subscribe, and share.